So now we're going to be looking at algebraic expressions. We need to be comfortable with moving back and forth between words and expressions. So expressions are anything that include variables and numbers, or it could just be variables or just be numbers. So 7 fewer than a number x. So here my key words that are really poking out to me are fewer than. So fewer than tells me I have this number x and I want 7 fewer than that. So 7 less than that. If I want less than something, then I'm going to take away. So my answer choice will be 3x minus 7. So you really want to look for those key words that are telling you what operation to use: addition, subtraction, multiplication, or division. To model scenarios with algebra, we need to first identify the action that is suggesting the operation. So for example, in the last one, saying fewer than, I knew that I was taking away. Then we need to define our variables and let everyone else who is looking at our work know what we are letting these variables represent. So yes, you have to tell me if x is the number of flowers, you have to say x equals the number of flowers. And then we have to represent the actions using the variables and the operations. So we want to bring together the numbers, the variables, and the operations to write one cohesive expression. So I'm going to start with $20, and every week I'm going to save $6. What expression models this? Well, let's go ahead and figure out what our unknown value is. It looks like I'm not quite sure how many weeks I'm talking about. So weeks is going to be my unknown value. So let's let W equal the number of weeks. So that means on week 1 I have $6. Now week 2, I've gained the $6 from week 1 as well as $6 from week 2. So that means now I have $12. Week 3, now I have the $12 I had before plus 6 more, so now I have 18. So how can I represent this in some sort of expression? Well, it looks like it's 6W, where W is the number of weeks, because 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. But remember, we are starting out with that $20, and I am saving $6 each week, which means this word save is telling me I need to add how much I'm getting each week to the $20 I initially started with. So this is going to be my final expression. So to evaluate an expression means to have an expression and then take some known value of that variable that's in the expression, plug it in, do some order of operations, and then end up with a final answer that is just a number. So I'm given an expression and I want to evaluate it at a equals -4 and b equals 5. So everywhere I see an a, I'm going to put a -4, and everywhere I see a b, I'm going to put a 5. I'm going to substitute those values in. So 7 times a, which is -4, plus 4, plus 3 times b, which is 5, minus 8. I want you to notice here that these parentheses and these parentheses are different. These parentheses are actually just acting as multiplication. They're not really doing any separating in my expression. Here, these parentheses are telling me to do what's in the parentheses first so that I can follow my order of operations. So order of operations says, please excuse my dear Aunt Sally, or PEMDAS. So I'm going to do my parentheses first. So I must simplify what's in the parentheses. So -4 plus 4 is actually just 0, so that's 7 times 0. I'm just going to rewrite everything. And now my order of operations says do exponents. I don't have any. Multiplication from left to right in the problem. So 7 times 0 is just 0. And then 3 times 5 is 15. And I'm going to bring down my -8. And now division, I don't have any division. Adding and subtracting from left to right. So I have addition first, so I'm going to do 0 plus 15, which is just 15. And then I'll do my subtraction, 15 minus 8, which is 7. You should be able to do all of these problems without a calculator. Whenever I have an expression that is a product of a number and a variable, or it's just a number or a variable, it is called a term. Now, a coefficient is the numerical factor of this term, so it's the number that's attached to the variable. A constant term is a term that has no variables at all. Now, we can add terms to form longer expressions, just like we have right here. So -4 and 7 are the coefficients because they are attached to the variables. They are multiplied. They are part of the product. And then 6 has no variables at all, so it's just a constant term. So whenever terms have the same variables raised to the same powers, we call those like terms. So for example, here I have 3x squared and 5x squared. Both have the same variable x and the same power 2 on that variable. So these are like terms. I also like to say that they have the same last name. So the last name here in this term is x squared, the last name here is x squared, so I can just add their first names, which is 3 and 5, and I get 8x squared. So just like John Smith and Karen Smith have the same last name, therefore they can go together, they can live in the same house. So 3x squared and 5x squared can come together and live in the same term, 8x squared. Same thing here with the 9y cubed z and then -4y cubed z. And when you bring them together, you would just combine the coefficients, 9 and -4, so I would get a positive 5y cubed z. Here are some properties of simplifying algebraic expressions. I expect you to know these properties and be able to use them. Alright, so let's simplify this algebraic expression by combining like terms and rewriting it into a simpler form. So first, let's look at all these guys and see who has the same last name. So this guy's last name is x squared, this one is y squared, and then x squared. So it looks like these pair up, and then these pair up. So bringing these together, I'm going to just take their first name, so 7 minus 4, and tack on that last name. Simplifying that, I get 3x squared. And then I have 3y squared and 2y squared, so adding their first names, tacking on their last name, I just get 5y squared. So bringing those back together, I get 3x squared plus 5y squared is the simplest form of that expression. Now obviously this in-between step is not necessary. If you don't need to write that, you can just hop down to the simplified form. Alright, so here we want to do the same thing. We want to combine like terms, but before I do that, because of these parentheses, I have a little bit of work to do. I need to do some distributing. So I'm going to go ahead and distribute this negative to each term and distribute this 2 to each term. So rewriting that, I get negative 3k minus m plus 2k minus 8m. Now I can take a look and see what are like terms. So what has the same last name? This guy and this guy both have a last name of k. This is an m and this is an m, so those will come together. So I'm going to have negative 3 plus 2, tack on that last name. The opposite of distributing is factoring. So I'm factoring the k out and putting it as my last name. And then I'm going to simplify. That's just going to be a negative k. And then factoring out that m there, I have a negative 1 minus 8m. So I'm going to have negative 9m. So putting those together into one simplified expression, I get negative k minus 9m as my simplified form. So go ahead and try these out. Make sure that you write the problem as well as your work and your answer in your notes.